This is Josh White with JW Math Tutoring. In this video, I'm going to go through Bluebook PSAT 10 Practice Test Number 1, Module 2B, the harder of the two second modules. So let's go ahead and get started.
But life is a dream that calculus could never predict.
Before I begin going through this Bluebook Digital PSAT Practice Test Number 1, the Grade 10, Module 2B, the harder of the two second modules, I just want to mention a couple things. First, of course, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, check out the videos for the other modules from the same test, both Module 1 and also Module 2A, the easier of the two second modules as well. The other thing to consider is that for some of these problems, I'm going to show multiple methods you can use to solve them. So the total time to go through these 22 problems may be longer than the allotted 35 minutes. But again, that's only because I'm going through maybe 2 or even 3 different ways you can solve some of these problems. Whereas on test day, you wouldn't need to do that. All right, so let's go ahead and get started then with problem number 1. Here you basically have some text, and you have to translate it into an inequality. And essentially we have offices being cleaned, homes being cleaned. The most that can be cleaned per day is 14. So that means basically we're going to need a less than or equal to 14, which eliminates B and D. And the offices and homes are both being cleaned, essentially together. So we want F plus H to be less than that. We don't want that. It doesn't say anything about the difference between, no more than 14 more offices being cleaned compared to homes. That's what would have to be for like letter C to be correct. So the correct answer to this one is just going to be letter A. Next, question number 2. You have a problem, and you have an equation here with a constant. It has infinitely many solutions. What is the value of k? All right, so the quickest, fastest, easiest way to solve this is to recognize that for this to be infinite solutions, the left side has to be identical to the right side. So that's already true for the x parts, 3x and 3x. That means k has to equal 21. And you could go to Desmos, and you could check this in Desmos. You just graph 3x plus 21 and 3x plus k, and say k equal to 21, and you'll get the exact same line overlapping itself. Next up, question number 3. You're given a graph, and they want to know what the y value is of the y-intercept of this line. So you can just plug in 0 for x, because they already tell you here, x is 0, and this will drop out, and then you just divide by 2, and you get y equals 9, which is the correct answer. Or, of course, you can go to Desmos, and you can just type in the line and graph it. Let me just erase this so that we can see the full equation again. 12x plus 2y equals 18. Slide this down here. And we can see there's a clickable point right here at 0, 9. So this just confirms the correct answer is 9. All right, next problem. For number 4, here you have a graph. It's actually a quadratic function, and they want to know the interpretation of this point right here, which is 1, 4.8. So x here represents time, number of seconds. 4.8 represents height. So the 1 here, the x, has to be a number of seconds. So when we're looking at the answer choices down here, we need something with like 1 second. So B is obviously wrong. B says 4.8 seconds. No, that doesn't make sense. C, 1 meter. Again, no, that was wrong. D, we can't quite read the full thing. If I scroll down, launched from an initial height of 4.8 meters with an initial velocity. No, again, it's got to be 1 second. So the correct answer for this one is just going to be A. Basically, after 1 second, the ball's height, which is the y value, that's what's being graphed on the y-axis, is 4.8 meters. And that's it. Next up, question number 5. Here you have a question that deals with the concept of margin of error. So the mean value for this, they tell you, is 20.5, and they tell you the margin of error is 1. So the general conclusion for this is that you're going to take the mean and you're going to add the margin of error to it and subtract the margin of error from it. And that's going to give you a range. So in this case, 19.5 to 21.5. Basically, you expect the mean, the true mean, to be in this range, between those two numbers. And technically, the percent confidence you have is whatever confidence level the survey is conducted at. That's not tested on the SAT, so whatever. Don't worry about that. But the main takeaway here is if you have a mean and you have a margin of error, the general conclusion or takeaway is that you expect the mean, the actual true mean, to be between the margin of error, or sorry, the measured mean plus the estimated mean. Let me say it that way. Estimated mean plus the margin of error value, and the estimated mean minus the margin of error value. So the correct answer to this one is just letter A. All right, next up. This one is a frequency table. However, you don't actually have to calculate anything on this problem because it just wants to know what is the minimum value. So for the values, we're only looking at the first column. The second column, the frequencies, are irrelevant to this question. So there are 4 possible values here. Which one's the minimum? Well, it's just 19. It's the smallest one. And that's it. Nothing else that you need to do. All right, next up, question number 7. Here you have a formula. So we're going to solve this in terms of n. There's multiple ways you could do this. The fastest way is to actually divide by 5 first, and then just subtract p. So you get 7m over 5 minus p equals n. So let's see, do we have that as one of our answer choices? 7m minus 5, 7m over 5 minus p. Yes, it is answer choice B right here. So this is how you could do it by hand. However, I will show you how you could do this entire problem in Desmos. So what we want to do is first type the original equation, but as a regression statement. By the way, if you want more practice on solving formulas using this method, check out my Ultimate Desmos Guide to Digital SAT Math. I will put a thumbnail on the screen which shows a specific video that covers how to solve formulas in it. All right, so now that we've done that, notice it's giving zeros for all the values, which in this case is not acceptable because it says m, n, and p have to be positive numbers. So first, let me just set n equal to whatever, 1.2. Okay, now it's still giving me p as a 0, so let's just set p equal to 2.3. All right, so now perfect. I have positive numbers for m, n, and p. I'm now going to type the answer choices and see which one of them is equal to the value of n, which is the 1.2. So for answer choice A, it is not equal to 1.2, so it's not the correct answer. Answer choice B is equal to 1.2. That is the correct answer. At this point, you wouldn't need to go any further, but just to show you that the others will also be incorrect. Okay, clearly not equal to 1.2, and 7m minus 5 minus p. Not 1.2. This just confirms that letter B is the correct answer. All right, next up, we have a linear function here and wants to know which of these tables gives the 3 points that are on the graph. Okay, so again, for this one, you don't actually have to do any work because this function right here is just y equals 39. It's a horizontal line. You know, you start at the origin, you go up 39 units, say to like 0, 39, and then you just draw a horizontal line like this. So all of the points are going to need to have 39 in the f of x, or in other words, y column. So the correct answer for this one's going to be B. I'll just scroll down to show you D is obviously not correct because it's got a positive and a 0 and a negative, but that's it. That's the answer for this problem. There's no other work to do really. And if you weren't sure of that, you could go to Desmos, you could graph it out and see the line and then realize, oh, every single point is going to be something, comma, 39. All right, next up, you have here a rectangle, and you're told that its length is 15 times its width, and then they give you the function here representing its area, 15w times w. So what is the interpretation of 15w in this? Okay, so remember, length equals 15 times width. They tell you this is the area, so the area, of course, is length times width, so area is 15w times w. So the 15w here just represents the length of the rectangle in feet, and that's it. It's just answer choice A, just matching up, the corresponding parts. All right, next up, we have a problem that we can use linear regression on. Basically here you're given 2 points, x and y values, and it tells you there's a linear relationship, i.e. a line, and it wants to know what the answer is. So I'm just going to go straight to Desmos rather than do all this work out by hand. I'm going to let Desmos do the work for me. I am going to type in the points. Now, here you could click the regression button, and then it's automatically set to choose linear as the default, which is what we want. Notice 65x plus 90. In this case, it's h instead of x, but that doesn't matter. It's still the same equation here. It's going to be letter C. However, I'll just show you also technically the way I normally do it is I type y1 tilde mx1 plus b, and then I would see here m is 65, b is 90. Okay, that corresponds to answer choice C. Regardless, whichever way you do it, the correct answer for this one is C, and that's how you can solve it. Next up, we have question number 11. So here we are increasing a value, a positive quantity of value, by 43%. Okay? And W is what we're starting with, so which of these represents increasing it by 43%? So if you think about it, okay, you have W, then you have 43% of W, which is equivalent to 0.43W. So you're increasing W by that much, meaning you're adding to it. So what do you get when you add W plus 0.43W? You just get 1.43W, which is answer choice A. Now, an alternate approach that you could take with this is, I would say, let W equal the number 100. This is the strategy of picking numbers, okay? So, what's 43% of 100? Well, it's just 43. Again, you could go to Desmos to calculate it, but, because I chose 100, I just know that, it's going to be the number itself. So I increase it by 43, okay? So I take the 100 that I started with, I increase it by 43, I get 143. Now you just run through the answers, and you just see which of these answer choices gives me 143. And the easy way to do this is say, let W equal 100, and then just type them all in. 1.43W, is that 143? Yes. 0.57W, no. 43W, no. 0.43W, no, not correct. So that's just an alternate approach you could take using picking numbers to solve this one as well. All right, next up, we have a linear inequality. It gives us the graph, and it wants to know basically what the equation is for this. So there's multiple ways you could do this. One way to do this, might not be the fastest way, but one way I would do this is I would say, okay, 0, 4 is in the solution set to this. So I'm going to go down here, and I'm going to plug in 0 for x and 4 for y and see which of these is true. Notice when I plug in 0 for x, basically all of these drop out. So I'm really just looking at 4 less than 1, 4 less than 1, 4 greater than 1, 4 greater than 1. Okay, well the first two obviously are wrong. Okay, 4 is not less than 1, and if a point is in the solution set, it makes the inequality true. So it's got to be C or D. Now, at this point, what you could do, and this is the quickest, easiest way to do it, is notice this line right here, which is part of the boundary of the graph, has a negative slope. Okay, the m value is negative. Therefore, it has to be D, because D has a negative slope. C has a positive slope. In other words, if you graphed out line C, it would like go through at 1 and it would go up 4, right 1. Up 4, right 1. Look like something like that, except it would be dashed, of course. So the correct answer has to be D. That's one way to figure it out. You could also, though, maybe this would be quicker because you're really only changing the inequality symbol or a single sign. You can go to Desmos and you can graph this and you see, does this match the original graph? Okay, obviously it does not because the line is, basically positive slope and the graph has a negative slope. Okay, then I look at this one. Does this match the graph? This is B. No. Notice the shading's on the other side. The shading doesn't match, so that's not correct. All right, now let's check C. This one doesn't match. The line does not look the same. It has a positive slope, but it really wants a negative slope. And now D, okay, yes, this one matches. The line has the same slope. It's a negative slope. It's shaded on the right side of the graph. So that's an alternate, method you could use. Maybe that's quicker than, picking a test point and plugging it in. And if so, that's, totally fine. All right, next up, what is the positive solution to this equation? So here's the thing. You can factor this problem, and I will just show you, how it's going to factor. I know it's going to be 5x and x, and then you have to pick factors of 24. Well, sorry, negative 24, and you need them to add up to negative 37. So it's going to end up being negative 8 plus 3, and then there's technically two solutions here, negative 3/5 and positive 8, because we set each of these equal to 0 when we solve it. 5x plus 3 equals 0, minus 3, and then divide by 5. X minus 8 equals 0, plus 8, plus 8. Okay. Now, so the correct answer is going to be C, positive 8. However, it is so much faster, quicker, and easier to just go to Desmos and to just graph out the left side of the equation and then look for the x-intercepts. Okay, what's the positive solution? Well, it's positive 8. It's right here. You could also technically graph the equation like this, just type the full equation, meaning equals 0. Then you're looking at the vertical lines, okay, and obviously this one is at 8, this one's at negative 6, well, the positive one's at 8. So however you want to do it, it's so much faster and easier just to do this one in Desmos. All right, next up, question 14. So you're told here that this board has an area of 874 square inches, and there's a pressure of 19 pounds per square inch. What's the total force in pounds exerted on this board? So here's the thing. Even if you don't know the relationship between area and pressure and force, that's, you're not expected to know that. That's totally fine. What you have to pay attention to is the units. The total force, which they're asking for, okay, is in pounds. So we have a pounds per square inch, and then we have a square inch. So notice if you multiply these two numbers, the square inches will cancel out, and you'll just be left with pounds. And that's all you have to do on this one. It should be 16,606. Let's just go to Desmos to confirm. Yep, there it is, 16,606. That's what we're going to type in. And there's nothing more to do for that problem. All right, next question. Here you have a equation of a line, and they tell you that the system has infinitely many solutions. What could be the second equation? So there's a couple different ways you could do this. You could technically look at multipliers between all the x and y, x term and y term and number term. So if you wanted to do that, I'll just mention that real quickly. I'm actually going to use Desmos for it. So what I mean by that is negative 15 times what number, and I'm going to use regression to get this, is equal to 12. So for example, if I look at answer choice A, the multiplier is negative 0.8, at least for the x's. So is it this? Is it that it has to be the same number for both the x and the y and the number term, the constant term on the right, in order for it to be infinite solutions? So is that true? So in other words, if I take 25 times s, my multiplier, okay, notice it's negative 20 here, not positive 20. So therefore, A is wrong, because the x and y don't have the same multipliers. Also notice their signs are opposite. So therefore, in the correct answer choice, the x and y have to have opposite signs. They can't have like a negative and a positive here, and then both be positive, or say both be negative, if if it's an infinite solution thing, meaning it's the same line twice. So that also rules out B, by the way. So now you're down to you're down to C and D, and notice in C and D it's technically negative 15 and it's negative 12, which means the S value, the multiplier, is positive 0.8 that you're multiplying by for both these. So the x terms are the same, the y terms are the same. So then the question just becomes, what does the number term have to be on the right? 65. No, sorry. I want to edit it down here. Okay, 65 times s, it needs to be positive 52. Therefore, the correct answer for this one is going to be letter C. Now, here is probably the much faster, quicker, easier way to do this, just straight in Desmos. Graph the lines out. There's the original line. Okay, here is answer choice A. I'm going to graph it. Does it overlap it completely, showing only one line? No. That's what I'm looking for with infinite solutions. So the answer is no. So A is wrong. What about B? Nope. Doesn't overlap it. Still wrong. Okay, now what about C? Yes. Notice there's no other line on the graph here. When I turn this one off, this one overlaps it completely. That's how you know it's infinite solutions. And just to check D, nope, they're parallel. D would be the answer if it was no solution, but it's not. It's infinite solution, so correct answer C. All right, next up we have a linear interpretation problem with systems of equations. So if you go and read through this problem here, basically you have this trip, it's 4 hours in total, and this bus is traveling at two different speeds. You know, it's traveling at one speed, a slower speed for some period of time, and a faster speed for another period of time. So x is the faster speed because that's the highway speed, and y is the slower speed because that's the local road speed. The faster speed, the 55, the slower one, the 25. All right. So now let's look at setting up some systems of equations. So first, we know that the total time, oh, and also we know x is time and y is time, okay? So one equation is just going to be just time. Time spent on highway plus time spent on local roads together has to add up to 4 hours. So one equation has to be x plus y equals 4. So this is out, and this is out. So we're down to B versus D. Now, the only difference between these two is basically like the different coefficients. So you just have to figure out, okay, the highway speed, like I already wrote down, is 55. So that's going to be associated with the x, the highway time. So 55 with the x, and then the local road speed, the 25, that's associated with the y. So therefore, the correct answer for this one is going to be letter B. All right, next up, we have a graph, and it's asking for the average rate of change from x equals 2, which is this point right here, to x equals 6. So average rate of change is essentially just finding the slope of the line that connects the 2 points. In other words, it's change in y over change in x, i.e. it is going to be 8 minus 6 over, and then the change in x, well, 6 minus 2. So I get 2 over 4. So you could enter 1/2. You could also enter 0.5. You could also technically enter 0.5. You know, any of those would be correct. And you could also get this technically just by counting on the graph. You know what I'm saying? You could start here and we go up 2, and then we go right 1, 2, 3, 4. So 2 goes on top, 4 goes on bottom. And you could also, of course, just take the points and go to Desmos and like put them in the table and do linear regression and calculate it that way, just to get the slope, you know, between the 2 points as well. All right, question 18. Here it's talking about two similar polygons. And basically, it gives you some extraneous information that is irrelevant to the problem, like this part right here. Basically, it gives you the scale factor, but we don't need the scale factor. You're told the measure of three of the angles in the quadrilateral, 30, 50, and 70. It wants to know what's the measure of P prime. So these two figures are similar, and the angles are given such that the corresponding ones are in the same order, meaning P corresponds to P prime, and Q corresponds to Q prime, and R prime, so on and so forth. So the measure of angle P is equal to the measure of angle P prime. What's the measure of angle P? Right here they tell us it's 30 degrees. What's the measure of P prime? It's 30 degrees. Correct answer to this one is B, and that's it. All right, next. Here you have a function which represents the perimeter of a rectangle with a length of x and some width, some value which we don't know. What is the width of this rectangle? Okay, so if you remember, perimeter is equal to 2L plus 2W. So in this formula, x represents my length. So this 244 here represents the 2W part. Okay, so therefore, two of the widths together add up to 244, or if you divide this, you should get the width equal to 122. Therefore, the correct answer for this one is just going to be letter B. Next, we have an absolute value equation here. This one is tricky because of the way that it's worded, but it's actually not that difficult a problem to solve. Basically, what this problem is saying is, and we can do this with k, or you can do it with x, or whatever letter, doesn't matter. Basically, what it's saying is, for one of these values, when you plug it in and then you evaluate it, the answer you get as your output is equal to 3 times the number you started with. Like, that's all that this is saying right here with this f of k equals 3k thing. So, traditional way to do this would be just plug in k here, okay, and then set it equal to 3k. And then you get 59 minus 2k equals 3k, or 59 minus 2k equals negative 3k. Let me just take 1 second and check my notes. And then if you go ahead and solve this first one out, you get 59 equals 5k, because I add 2k to both sides, and then divide by 5. K equals 59 over 5. And that is the correct answer. Basically, it's letter A. All right, so that's one way to solve it. But here are some quicker, faster, easier ways to solve this. First, you could go to Desmos and you could just back solve this. And you could say, you could define the function. Okay, so there is the function, right? And now we're going to plug in the number. And now we're going, basically what I need to check is, does this number times 3 equal my output? Meaning, this is 3k and this is my output, and these need to be the same. And it is, because it's the correct answer. Notice now if I change this to 2, and I change this to 2, notice these do not equal. Like, 3 times the number I'm plugging in is not equal to the output you get. And same thing if you change this to 177 over 5, and then here. Again, they're not equal. And then lastly, let's just check 59 itself. Again, they're not the output does not equal 3 times the number I inputted. So this is an alternate approach you could use as well, just to solve this in Desmos. Okay, next up. This is a fairly tricky question dealing with similar triangles. There are also multiple ways to solve this, which I will show you. This question has also been featured on official exams multiple times, so just be aware of that. You may see this coming up again in the future. Okay, so we have a right triangle. That's not right. It's B. That's the right angle, not D. I'm going to put A at the top. I'm going to put C at the bottom. And you have an altitude right here, D, which is perpendicular to the hypotenuse. Okay. AB is 15. AC is 23 greater than AB. So 15 plus 23 is just AC. This whole thing is 38. Okay. What is the ratio of BC to BD? Okay. Here is the fastest, quickest, easiest way to solve this. It is basically to do the following. Take the original triangle, and I'm just going to draw it out over here. Okay? So it's going to look like this, 38, 15. Now, when you have this scenario where you have a right triangle and an altitude drawn to the hypotenuse, it makes three triangles. You have the original, and then you have two smalls. All three of them are similar to each other. So I'm going to now look at this triangle down here, and I'm going to reorient it so that it's in the same orientation as the large one. So D is down here corresponding to B because D is the right angle. The question is, what do you do with C and, technically angle B in this one? Like, where do they go? Here's the way I like to think about this if you're having trouble, like, remembering. So, essentially, say that this angle up here was like 50 degrees, right? Then this angle would have to be 40, because these two have to add up to 90, looking at the overall triangle. And then this would have to be 50, and this would have to be 40. Okay, so now this is 50 and this is 40, right? So looking at just the small one down here, the 40 has to correspond to the 40, so C has to go down here. And then the 50, which is B, has to correspond to the 50 in the other one, which is A. Now, this is not the exact measure of these angles. This is just a dummy value I picked to help me orient them in the correct manner. So now I can look at this and I can say, okay, BC over BD. So BC is the hypotenuse. Therefore, that will have to correspond to AC, which is 38. And BD, which is this leg over here, across from the quote 40, even though it's not actually 40, will correspond to AB, which is 15. Therefore, the correct answer to this question is letter D. It's 38 over 15. Now, here's a second way you could solve this. For the second method to solve this problem, I'm actually re-recording, essentially, the process just to make sure it's a little bit clearer, a little bit easier to follow than the initial recording that I did. So that's why I'm not in the Bluebook app right now. I'm just basically using a screenshot of the problem. I also have the Desmos, you can see like web app, the College Board version up. And so I'm going to walk through now the second method that you can use, probably the longest one or most complicated method, because you'll see the third one using basic trig right after this is a little bit simpler, a little bit easier. But anyways, here is how to solve this problem in an alternate method if you don't recognize the similar triangles. All right, so first thing I'm going to do is just draw the picture down here. Okay, so we've got a right triangle, we've got A at the top, and we've got this perpendicular line right here intersecting at point D. Okay, we already know, again, we know AB is 15, we know AC, the whole thing here is 38. The basic process we're going to go through is, first, we're going to find BC. We're just going to use Pythagorean theorem for that, all right? That's simple enough. Then, we're going to use BC and AC along with the geometric mean properties to find DC. Once we know DC, then we can use BC and DC and the Pythagorean theorem to find BD, and then we can set up the ratio of BC over BD. Okay, so step one, basically AB squared plus BC squared equals AC squared. Pythagorean theorem on the large triangle, right? This is 15. This we don't know. AC is 38. Now, normally I would just go to Desmos and I would just type in like 15 squared plus whatever variable squared tilde 38 squared. And that would give me the exact value. But the problem is I need to use that value in another calculation or in another regression statement. And you can't carry values between like one regression statement to another. So I'm actually going to do this out by hand, so to speak, meaning I am going to do, slide this down here, the 38 squared minus 15 squared. And notice that's 1219, which means BC is equal to the square root of 1219. All right, so now, so down here, 1219. All right, perfect. Next, we need to find CD. Okay, so in other words, this segment right here. The way we do that is we use basically a theorem from geometry which says if you have a right triangle and you draw an altitude from the right angle to the hypotenuse of that right triangle, i.e., it's perpendicular to the hypotenuse, line segment from the right angle perpendicular to the hypotenuse, then either leg of the triangle, in this case BC is one of the legs, will be the geometric mean between the entire hypotenuse and the part of the hypotenuse that is closest to the leg you are looking at. In this problem, what that means is you're going to set up a proportion that looks like this. BC is the leg. That is our geometric mean that goes in like bottom left, top right, or you could technically put it top left, bottom right, doesn't matter. But the point is it's going to be multiplied by each other. It's going to be squared. And then the two things it's the geometric mean between are DC, the part of the hypotenuse closest to it, and AC, which is the entire hypotenuse. Okay? So now what we can do is just go ahead and plug in DC we don't know. BC is root 1219. So we plug that in. And then AC is 38. So now when you cross multiply, you get 38 DC equals just 1219 because the two square roots, cancel out. Again, just cross multiplying. Divide by 38. So DC is equal to 1219 divided by 38. All right? 1219 divided by 38. And again, you could go into now if you wanted to, you could go into Desmos and you just get the exact value here. Whatever, I'm just going to call that D for whatever for right now. Okay, now what we have to do next is we have to do Pythagorean theorem again, where we have looking at only the small triangle on the bottom. In other words, this triangle right here. So that means we're going to have BD squared plus DC squared equals BC squared. Again, the right angle is right here, therefore BC is the hypotenuse. So now if we plug everything in, BD squared, we don't know, that's what we're solving for. DC squared is whatever, the 1219 over 38 squared. BC is the root 1219, square root of 1219, and that gets squared. So this, I would now just go ahead and solve in Desmos, and we're just going to get the answer for BD. So the way I would do that is, we can't really see it because it's getting covering up the root 1219 there. So let's just call this B. All right, so this is, B squared plus D squared. Again, DC is the 1219 over 38. I already defined that as D in the previous step. And then we can use regression, and then we have the square root of 1219 squared, or you technically could just type 1219 because the square root and the squareds cancel out, however you want to do it. So this is the value of BD, the altitude of the triangle, 13.7891. I'll just abbreviate that. 13.78. Did I read that correctly? No, 191. 13.78191. All right, now, last step. We just need to put BC, which is root 1219, over BD, which is the 13.78191. So, square root 1219, and then B which I just found in the last step, that's the value of BD that goes in the bottom here. So I just put this over B, and notice here I have my answer, the 2.53 repeating. Now, the answers are all fractions, of course, so if I just click the fraction button, now I can clearly see, okay, I get 38 over 15. The answer is letter D, which is the correct answer. So this is an alternate method you could solve this problem using. It involves, again, Pythagorean theorem multiple times. It also involves knowing the geometric mean properties. It's probably not faster or quicker than the first method, which has similar triangles, or this third method, which you can watch now, that involves basic trig, but it is an alternate approach that you could use. And try to run through this as quickly as possible. Okay, A, B, C, 38, 15. Okay, first of all, we already know this is root 1219. Like I did that in the previous thing. You just do 15 squared plus BC squared equals 38 squared, and so on and so forth. Okay, so you get BC equals root 1219. Okay, now to get BD, we're essentially going to use some basic trig. So what I'm going to do is I'm going to first find the measure of angle C by noting that. Let's see, no, I don't want the tangent. I want to use a sine because I want to use the two given values. So I know that sine of C is equal to the opposite, which is 15, over the hypotenuse, which is 38. So C is equal to inverse sine of 15 over 38. All right, so let's calculate that. Now, this is in radians. I need to click here, change it 2 degrees. Okay, so that's the measure of angle C. It's like 23.2495 whatever degrees. 3.2495. Okay, perfect. Now I can look at this small triangle, and I can find both BD and BC. So I'm going to just call this D. I'm going to just call this B. I can find both of these by using this angle and by using this side. So for example, 1219 is the hypotenuse, okay? D is the adjacent. So that means the cosine of C equals D over root 1219, the hypotenuse. B is the opposite. That means the sine of C is equal to the opposite over root 1219. And then you can multiply both these over, and we're going to get in Desmos, D equals cosine of angle C times square root 1219. All right, I have to probably put this in front. There we go. B is equal to square root 1219, and then times the sine of angle C. So there are my two side lengths, and now for the ratio of BC over, actually I just realized I don't even need, the only one I need, sorry, I already have BC. The only one I needed was BD. I didn't actually, like this you don't need to calculate for this step, so that's just whatever. An extra wasted step that, you know, we don't even need. Really, this is all I have to calculate. Because now I can do BC, which is square root 1219, over BD, which is just letter B in my calculation, and notice we get the same answer, and click to a fraction, it's 38 over 15. So that's how you could use basic trig to figure this out. So, in any case, it's a long problem. I showed you 3 different methods to use. Pick the one that you understand the most, the one that's most intuitive for you, the one that you followed the best. I personally prefer either method 1 or method 3, but that's how you solve this problem out. All right, last question, number 22. Here you have a quadratic equation, and you're told that the sum of solutions is equal to this expression. What is the value of this constant k? First, I'll show you how to do this by hand. Then I will show you how you could do this in Desmos. So by hand, you are going to hopefully remember the sum of solutions shortcut formula, which is negative b over a. So in this problem, notice that would be this negative is from the formula, and then this whole thing is the b term. So I'm just going to distribute this. I'm going to make it negative 16a minus 4b. In other words, this negative I'm distributing. A is positive 64, okay? Then they tell us this is equal to k times 4a plus b. All right, a couple things. This negative in the formula will cancel out both of these, so it will become 16a plus 4b. And then over here, notice now what you can do is you can factor out a 4 here and turn this into 4 times 4a plus b. The reason that helps is because now you can divide by 4a plus b on both sides, and it will cancel. And k is equal to 4 over 64, which is just 1 over 16, or as a decimal, I believe it's 0.625. And that's going to be the correct answer for k. Let me just double check. 1 over 16. Yep, 0.0625. All right, now, here's how you could solve the entire thing in Desmos. And this is not necessarily any quicker, but still, it's just something, useful to be aware of. What I'm going to do is I'm going to take the original, let me clear this off here. Okay, the original equation, just the left side of it is equal to 0. I'm going to type the whole thing into Desmos, except I'm going to do a regression statement, so every x needs to be x1. And then I'm going to do regression with this to a quadratic that's in its intercept or factored form. So because I can't use a and b here, I'm going to use c and d to represent the two roots or the two solutions. Also, if you want more information on how this process works or how to do this specific technique, I will post, it's in my Ultimate Desmos Guide to Digital SAT Math, I will post a thumbnail on the screen for the specific video that covers this. Okay, this how to approach sum and product of roots problems. The next step we need to do is we need to set up the what I call the constraint equation. And this is the one where it tells us the sum of the solutions is equal to this k times 4a plus b. Here, my two solutions are c and d. So I do c plus d equals, and then k parentheses 4a plus b. Now, it doesn't work if it has multiple letters on both sides. You need it to have only one letter on one of the sides, preferably the left. So I'm going to subtract d over to the right in order to get this to work. And then the last step is, because it's a regression statement, I have to add an element list for x1, and I'm going to go with negative 2, 0, 2, and then add some more values in. Now, we do want to double check here a couple things. It tells us here a and b are positive constants. Now, notice though, in the regression, a is not a positive constant, so that's a problem or an issue, even though it's giving me the right value of k here. Okay, k is 0.0625, or if you click on this, it's 1/16. Like, it's giving me the right value of k, but the a value is not positive, so technically, I would try to choose an a value that's like maybe something like this. And notice, okay, my a value is positive now. That works. My b value is still positive. That's fine. Okay. And notice it didn't change the k value. My k is still equal to 1/16. And if I slide this, notice k is not changing. So as I make it a positive number, the k value itself, it's constant. It's still the 1/16. You know what I'm saying? It's still the 0.0625. So that's how you could solve this problem entirely in Desmos using sum and product of roots techniques. Okay, so this was the module 2B, the second module, the harder one, from Bluebook Digital PSAT Practice Test number 1, grade 10 version of it. I hope you enjoyed this video. If you did, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Also, if you have any questions or comments or alternate solution methods, feel free to leave them below the comment section of this video. Third, check out the other videos from this practice test, basically the solutions to Module 1 and also Module 2A, the easier of the 2-second modules. And lastly, if you're looking to improve your knowledge of Desmos, please check out my Ultimate Desmos Guide to Digital SAT Math. It's over 6 hours of tips and tricks and instruction, and it includes 65 practice problems to help you ace the digital SAT math section.